In this video, we'll talk about how to find the equation of an ellipse given the foci and the co-vertices. So, an ellipse is written in the following form: x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And the a squared and the b squared terms could be interchangeable, because if we have a vertical ellipse like this, then the a squared is written under the y term. But if we have a horizontal ellipse, then the a squared is written under the x term. So keep that in mind. So let's check out an example. Let's say we have some ellipse where the foci are located at 7, 9 and negative 1, 9, and the co-vertices are located at 3, 12 and 3, 6. So when we're doing these types of problems, it helps if we can just sketch a quick graph to kind of get an idea of what's going on here. So the foci are at 7, 9. So I'll say 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 9, and negative 1, 9. Negative 1, 9. So here's our foci. And the co-vertices are 3, 12. We need to go all the way up to 12. So 10, 11, 12. So 3, 12. This isn't exactly drawn to scale, but it gives us an idea of what's happening here. And the other co-vertice is 3, 6. So 3, 6, somewhere around here. So recall that the foci will always be located along the major axis. So in this example, the major axis, or the longer axis, will be x-oriented. So that means our ellipse will look something like this. So we need to figure out what is the center of this ellipse, and then we can figure out what is a squared and b squared. So the center will have coordinates h, k. So in this example, the center of this ellipse will be directly in between the two foci. So we can see that both foci have a y-coordinate of 9, so the center must also have a y-coordinate of 9. And to figure out what the x-coordinate is, we can just take the average of the two x values of the foci. So we could say 7 plus negative 1 divided by 2, because this is the average of the x values. So 7 plus negative 1 is 6, so 6 over 2 is 3. So the x-coordinate of the center of this ellipse will be 3. So the center is at 3, 9. So somewhere right here. So we know the center. Now we just need to figure out what is a squared and what is b squared. Well, b is the distance between the center and the co-vertices. So this distance is b, and this distance is b. We know that the center is at 3, 9, and the co-vertices are at 3, 12 and 3, 6. So we can pretty easily see that the difference between these two y values to go from the center to a co-vertice is 3. So we know that b is equal to 3. Now a is the distance between the center and the vertices, all the way out here. And we don't know this value, but we do know that the following relationship exists. C squared is equal to a squared minus b squared, where c is the distance between the center and the foci. So we can see that the center is at 3, 9, and the foci, for example, one of the foci is 7, 9. So to go from 3 to 7, that's a distance of 4. So this distance right here is c is equal to 4. So plugging those values into this equation, we get 4 squared is equal to a squared, so we don't know a, minus b squared. We just found that b is 3, so 3 squared. So we get 16 is equal to a squared minus 9. So to solve for a, we can add this 9 to the left-hand side, so 25, 16 plus 9 is 25, is equal to a squared. And we can take the square root of each side to get a, and we can find that a is equal to 5. So we found the center, and we found a and b, so we have everything that we need to write the final answer. So we get x minus h squared. H, we said, is 3, over a squared, so a is 5, so a squared is 25, plus y minus k, so k is 9, so y minus 9 squared over b squared. So we said b is equal to 3, so 3 squared is 9. And we have all of that equal to 1. So that is our final answer. That is the equation of this ellipse.